The function of f of x is graphed. Find the domain and the range of f of x. Here the graph of f of x is this blue U-shaped curve. Well, let's start with the domain and recall that the domain is defined as the set of all possible inputs for this function, or all possible x values. Well, let's consider a few arbitrary x values. At x equals -9, if we draw a dotted line above that, we'd have an intersection with the curve. X equals -3, we have an intersection with the curve. X equals 4, we have an intersection. X equals 10, we have an intersection. In fact, for any of x values on this number line, if we draw a dotted line up or down, we intersect with the curve, which tells us that these x values are all possible inputs for the function f of x, and thus are part of the domain. And these arrows here at the end of this graph indicate that this function continues this behavior all the way to x equals -infinity and x equals +infinity. Consequently, any x value we choose on the x-axis will always be a valid input. If we were to draw a dotted line up or down from any x value on the x-axis, it would always intersect the curve and yield an output. Consequently, all real values of x are part of the domain. Another way to think about this is to project this curve onto the x-axis. If we were to do that, we'd get this line that looks something like this and would have arrows at the end of it. This is the line segment that shows all the x values that are part of the domain. Because these arrows at the end of the segment indicate that this segment extends all the way from x equals -infinity to x equals +infinity, this also shows that the domain consists of all real values of x. Thus, we can write the domain as all real x. Let's consider the range of this function, remembering that the range is the set of all possible outputs from this function. Well, let's choose a few arbitrary values. At y equals 9, if we draw a dotted line to the left, we get an intersection with the curve. Y equals 3, we get an intersection with the curve. At y equals -2, if we were to draw a dotted line through here, to the left and right, we get at least one intersection with the curve. In fact, we get 2. But at y equals -5, if we draw a dotted line left or right, we get no intersection with the curve. That means that there is no input, there's no x value that we can input into this function that would yield an output of y equals -5. In fact, we can see that all y values less than -3 are not possible outputs for this equation. However, all y values greater than -3 and including -3 are valid outputs. Again, these two arrows indicate that this function continues upward forever to y equals infinity. Thus, we can say the range of this function is all y values greater than and including y equals -3. Another way to think about this is to project this curve onto the y-axis. If we were to do that, we'd get a line segment that looks like this, which has an arrow here indicating that this line segment continues up to y equals infinity, and there'd also be a dot, a filled in point here indicating that y equals -3 is a part of this range. That's the line segment that we'd get if we reflected this on the y-axis, and that also gives the range. The way we express this range, indicated by this line segment, is y is greater than or equal to -3. And we're done.